Thank you all so much for coming today to our Brownbag presentation. My name is Kelly Hills, and I work here at DNR's Coastal Resources Division as part of our state's coastal management program. And we put on these brown bags as a way to allow people to come and present on projects that are relevant to coastal management, cultural and natural resource management, to just try to highlight some of the great work that's going on in the coastal region. We see some new faces today, so if you are interested in presenting in the future on any work that you're doing, we welcome anyone to come and do a presentation. You can reach out to me directly. If you're not receiving my emails already, then go ahead and sign in and make sure you put your email down on that sign-in sheet back there, and I'll add you to the list and Tyler wants me to talk until next time. Just because we have such a big crowd, do you want to do introductions or just?
Yeah, sure.
Or we'll just kind of go around the room really quickly and just kind of give a shout out of your name and affiliation and just to know who's in the audience really quickly. We'll start this way.
Hi, I'm Cassie Turpin. I'm with Camden County's Blood Protection.
Dwight Harris, I'm not with anybody. Rob Brown, as you know, good it was.
I'm
All Dibbler, same 3 letters. Jim on Special Resources.
Brian Osborne, CRE, Beth Burns, thing. Jill Andrews, guest fair.
Next finance year.
Russ Clark, I'm not from CRE. Gerald Timms with Lynn County Airport Commission.
Garrow, Alberson, City of Brunswick. Cohen Carpenter, GWES.
Larissa Harris, 109.
Ben Pierce with GWE.
Shad Duncan, CRE.
All right. Thank you all very much for taking some time out of your day to come hear this presentation today. I'm going to give you all a quick introduction, and then we'll get started. And just excuse my nasal situation going on right now. Hopefully you can hear me. We ready, Tyler? You good? Okay. So we're going to hear from 2 different speakers today. First, Garrow Alberson. He's the city engineer and also the public works director for the city of Brunswick. He's responsible for managing their entire storm drainage system, working on capital improvement planning, construction, maintenance, and also compliance with state and federal regulatory agencies. He's their certified floodplain manager and also serves as the, I'm so sorry. I don't have to sneeze. The community rating system coordinator. And Garrow's done a great job over the years in working through all of these projects, kind of incorporating and considering runoff reduction and also water quality treatment and overall efforts on how to reduce the impacts from flooding from storm events through all of that type of work. I'm so sorry. This is not going to happen for me today. Okay. Sorry about that. And then we'll also hear from Ben Pierce, who's a consultant with GWES working on this project for the city. Ben is an engineering consultant and has over 20 years of experience in the field of civil engineering, including work on environmental permitting and reporting, all sorts of aspects of municipal project management, as well as transportation studies. And prior to working with GWES, Ben was with the county. He was with the county public works department, overseeing lots of other municipal types of projects there. All right, so with that, please join me in welcoming both of our speakers.
Thank you. I'm not going to say much. I just, as she mentioned, I'm with the city. And as you know, if you're familiar with the area, we have our topography, we have serious issues with tide control, tidal flooding, that kind of thing. So we're looking at tide control structures all over town, trying to keep this tide out of our storm drainage system, trying to improve storm drainage where we can. We've looked at these coastal incentive grant projects. We've used the coastal incentive grant program on several projects now. We certainly appreciate Kelly and you guys working with us on that. We've been very glad to use the program and the funding. So this is one of those projects. And so we hired GWES to work on the technical side of the project for us. Ben and Cohen Carpenter have been handling this project for us. So I'm going to turn it over to Ben and let him talk to you about the technical side of the project. Thanks.
All right. Thank you, Garrow. Let's see. So as we go through the slides, we're going to give a little background about the project, some of the details of what we found, particularly some technical issues, some things that we found with the design aspects of it, the permitting aspects of it, and some of the kind of future plans for the project. So if you have any questions as we go through, please raise your hand, stop me, let me know if I'm not making myself clear. All right. So just to, as I mentioned, just a little bit about what we're going to talk about this afternoon. Talk a little bit about the project summary and the timeline, a few challenges that we had throughout the process, some of the background of the particular locations that the city wanted to implement tide control, some of the existing conditions, and then the project alternatives and the 90% plans. And we'll talk a little bit more details, engineering aspects of that, as well as some acknowledgments and some things that the city is going to do after this. So a little bit on the project summary. Obviously, some of the bad news, you've seen this as a scene from I believe, Hurricane Matthew, if I'm not mistaken. But a lot of coastal flooding here in this area, as many of you know. And so it may be difficult to see, but I'll just read it for us. So again, the problem is the tidal waters in stormwater outfalls, which it reduces the upstream drainage capacity and causes potential flooding. The purpose of the project was to identify, design, and permit tide control improvements at 3 priority areas containing 9 total outfalls. The priority areas include the area over by Lanier Plaza, Parkwood Drive at Towers Plaza, and then a few locations within the Riverside neighborhood. Improvement concepts include inline versus exterior check valves. We'll look at those details as we go through. And then also we looked at some bank stabilization in and around where the improvements were made. Permitting, of course, was through CRD, the U.S. Army Corps of Engineers, as well as GDOT, and then we're developing the final plans. So some of the timeline aspects, just to kind of give you some perspective about where we've been. Almost 2 years ago, we started the CIG project. We looked at conceptual improvements and alternatives report there shortly after, and then we had some coordination with other coastal communities later on in the process, as well as jurisdiction delineations, the permitting through CRD and the Corps of Engineers. Obviously, you can kind of look and see that was where the critical path was really taking us through. This past August, just last month, we finished up the final design, and then throughout the process, we've been looking at some community education and, of course, grant closeout here this month. Some of the project challenges that we've seen, we've touched on a little bit, but just to kind of expound a little bit more. Regulatory coordination has been a challenge for us, property owner coordination, other agency coordination with GDOT. Plan revisions, just going back and making revisions throughout the process. And then scheduling delays and city reimbursements always been a challenge for us as well. So here's a little bit of background about the project. So the City of Brunswick has a stormwater master plan, and this project identified several areas within the east side of Brunswick to improve for tidal control. And so, again, these communities here, you have an area over by Wildwood. This is the intersection of Macon and Talmadge. Again, just another indication of the type of problems that we're seeing throughout the city. When you have storm rain events and high tide conditions, really poses a challenge for the east side of Brunswick. Overall project locations. So as I mentioned, Lanier Plaza, within the GDOT right-of-way, we've got a few locations here, one of which is being constructed now, the Talmadge outfall, there at the outfall from Talmadge Avenue, I Street, and Cook Street, right here at the entryway onto the causeway. We have one location up at the end of Parkwood Drive, there at Towers Plaza. And then we identified 6 particular outfalls within the Riverside community. Giving a little more detail to the project locations. Lanier Plaza, again, 3 outfalls. This area, as you know, is densely populated with residential, commercial, and industrial area. And then, as you know, as it has a history of upstream flooding. So a few of these outfalls right here do not currently have. These 2, before, as the project was starting, did not have any tide control measures to them. The one here at Cook Street, we'll look at a few details as we go. It had a flap gate to it, but it was not functional. It did have a measure there, but it wasn't functioning at all to prevent tide from coming back in. The Parkwood outfall, this is a double pipe double culvert outfall is current tide gates are not functioning, working properly due to just a lot of organics, a lot of sediment buildup in front. And then this serves, as you know, a lot of residential and commercial areas. This outfall here, as you're turning onto Parkwood, this outfall serves a vast majority of the stormwater needs for this area. So you can tell the importance of keeping tide control there. Again, if anybody has any questions, please feel free. I don't mind. All right, looking over in Riverside. 6 outfall structures. The city is planning for further upstream improvements. And then again, as we know, flooding in this area is very, very common. Many of the outfalls that we looked at were just on the backside of properties, some down here on the southwestern corner. So it kind of gives an indication of where the improvements are right at the delineation line, right at the outskirts of the neighborhood. All right, here's the bad news. All right, you get a structure like this on Cook Street. All right, so obviously it's a non-performing tide gate. Right, not just with the organic growths, but there's no seal on the existing tide gate. Even though it's installed, it's not functioning. It's not functioning from getting sediment back into the system through the ebb and flow of the tide, and of course it's not preventing any of that tide water from getting back into the system.
Do you know how long that's been the case?
Been there for years. I imagine long before I came here. But yeah, this is as you know, it's right there at the entryway on the on-ramp as you're coming northbound 17. This is just to the right as you're going onto the causeway. Been there, I would imagine, been there for 10 to 20 years. All right, again, another outfall here from Lanier Plaza. Challenge here is there's no tide gate. So it's an open pipe end, again, an open area in front. Water levels, they flush from the bottom of the pipe during low tide events. When there's a storm event and you have a low tide situation, you do have the ability for stormwater to get out. But a lot of times the pipe's covered during high tide. The one that's it's one under construction now. Some of the challenges that we saw before the project began was a buried outfall. This is a picture of what the outfall looked like. If you can't find it, that's right, because it was all buried. The outfall that came from Talmadge out right where the construction is happening now. This picture, this scenario of where the marsh and the vegetation were overcoming the existing outfall, that's where it was located, right there, just to the west of where the shoulder and the guardrail are at. Again, just a scenario. You may remember what it used to look like before. Obviously, the improvements are being made today. Over in Parkwood, again, here's the bad news. The bad news is that you've got 2 non-functioning tide gates, and it's commonly, almost all the time, submerged with tide water. Again, downstream, this is the downstream condition, and this is again where the location is. And I think it's important to note that this was taken during low tide. You can tell the low tide situation here, and this is just upstream of that. So it's practically inundated with the tide all the time.
So then,
Yes. Jill.
was this just a function of the sediment building over time, or were they not built properly in the first place, or is it just hiding?
Yes, and probably yes and yes. Yes and yes. Yes. It is sediment accumulation over time, not just here, but further downstream. It could have been that these systems were built, where they had to maintain clearance over the pipes in order to provide, positive drainage or positive downflow into the system. But this is very common, and not just for the city, but for a lot of coastal communities, where you have outfalls, stormwater outfalls that cannot outfall higher than the existing marsh where they're intended to go. And so a lot of times this is the situation that agencies find themselves in. Yes. Not this one. We were talking a little bit before on the Cook Street outfall there to the causeway. I would imagine well over 20 years ago. And
21 years ago. Thank you very much.
usually these projects, they improvements like that, these situations that you find yourselves in, they usually don't happen until major infrastructure road projects happen, right? So I would imagine whenever this portion of 17 was widened, whenever there's some significant road improvements, that outfall improvements were made simultaneously. All right. And then in Riverside, similar situation where, again, buried outfalls, the outfall elevation's lower than the downstream marsh, infrastructure that's upstream, technically upstream. So you have an outfall here in the green. The blue lines is the stormwater infrastructure that goes back along the roadside. Whenever you have the tide that comes back in, again, it continues to eat away at the infrastructure that's not intended to get that type of treatment. All right, so let's look at some alternatives. How can you fix the problem that you have? Again, we've identified problems. The tide comes in comes into the stormwater infrastructure. It drops sediment, goes back out. It prevents stormwater from exiting the downstream system. So what are your options? Here's the options that we considered throughout the project. Really what's called like a spillover box, where this would be adjacent to the marsh, the jurisdictional area. Stormwater would come in from upstream and flow and bubble out and spill over into the marsh. We looked at, again, going back with more conventional approaches to stormwater control and tide control, where you have more circular flap gates. Some more recent technology that we've seen in this community and also in other coastal communities is, again, more of a sanitary type of approach, sanitary sewer approach, where you're installing inside the stormwater system like a backflow preventer, or what's called an inline check valve. Again, a very good approach from preventing the backwater or the tide water in this particular case from getting back into the upstream system. And then the other approach that we've seen, very commonly seen over last several years in this community, are the exterior Tideflex valves. So a very common approach. So these were the conditions, these were sort of the options that and alternatives that we investigated and reviewed. All right, so we're going to go through a little bit of the 90% plans, where we were at the time of permitting, where we were just a handful of months ago. So we generated the 9% plans for feedback from the city of Brunswick. And then the following slides we're going to show after this show some of the examples of what we saw, particularly at each location, okay? Some of the engineering drawings. This is the Lanier Plaza outfall. Again, you may recall it just had one pipe coming in and didn't have anything on the exterior. And so the solution here was a new head wall to help with the erosion around the end of the pipe, some grading around the outfall, as well as a new Tideflex exterior tide gate. This is here is Parkwood. This is a double head wall, double outfall pipe. Again, with this particular situation, we're having to install a new new head wall with Tideflex valves on the exterior, and then a little bit more of some improvements, some more clearing and bank stabilization around the ends of the head wall. Going further would require a tremendous amount of sediment removal and tremendous amount of permitting. And so just in order to achieve the goals of the project to prevent to preventing tidewater from getting back into the storm sewer system, the decision was made just to make the improvements here at the end of the outfall. And then this is one location at the end of Riverside, 5031, where you've got a small pipe, a 12-inch size pipe, outfalling between two residents, and again, bank stabilization and some downstream improvements out to the outfall. And again, this is a profile view, kind of a front view of the new head wall and the exterior Tideflex valve. All right. So here's your engineering tip of the day. Okay, your engineering tip of the day is that while conceptually you can understand placing a tide gate and a head wall at the end of a storm sewer pipe or storm drain pipe, a good engineer will always be concerned about the details of how to make that work. All right. So here's the process we went through. So this is the Parkwood outfall that we looked at just a moment ago. Again, older head wall, not really do anything with the storm sewer system, just focusing on what happens in and around the outfall. We surveyed the property and found out, well, here's where your inverts were. Your inverts were practically at zero, at sea level. A lot of your ground is higher than that. One of the challenges that we saw in designing a new head wall and a new tide gate is elevations, right? So conceptually, you can think, all you got to do is just put in a head wall and put in a tide gate. Doesn't always work that easily. So when you get into the design plans, you actually have to realize that these tide gates, these Tideflex valves, while they're very common, they don't match the size of the upstream storm sewer pipe. So in this particular case, the upstream storm sewer pipe was a 36-inch interior diameter. So that means 3 feet of your inside diameter of the pipe, right? You can't just go to Tideflex and say, hey, I want a 36-inch tide gate. And why is that? Well, the problem is that these 36-inch tide gates actually have an interior diameter of 36 inches. And so when you put in an interior diameter of 36 inches matching up with a 36-inch pipe, you have these bolt holes around it. They don't have anything to grab to. They don't have any head wall, any concrete to match to and anchor to. And so what you have to do is you actually have to design a tide gate much larger than both the interior and exterior wall of the pipe. Okay, so that's a little bit of a tip for the day. In addition to that, the apron, the head wall apron. You can't just go to your standard GDOT spec book and say, I want a head wall that's flush with the invert of the pipe. You actually have to drop the head wall elevation down so that the flange on the outside of this tide gate can actually fit onto the head wall. So you have to special design these aprons to be lower than the standard detail. Because if not, the contractor is not going to be able to install it. He's actually going to install the head wall higher than the invert, which is where the bottom of the pipe is. All right, so those are a few of the challenges that we found. Conceptually, again, you put a tie gate, put a head wall at the end of the pipe. Going through the details, you have to think about the details of the head wall, the details of the tie gate, and how do we make that work. So those are a few of the things that we went through. Any questions about that? It's okay. All right, moving on. Permitting and regulatory coordination. All right, so we had some GDOT challenges, right? So we had to go through the GDOT permitting process because we had 3 outfalls along GDOT right-of-way. So we dealt with encroachment permits, assistance with CMPA permitting, and then paving of Highway 17. Right, so there are some challenges about timing with that. U.S. Army Corps of Engineers, again, nationwide permitting. One of the challenges, one of the many, but primary challenges that we faced with the Corps of Engineers was, again, just a long delayed process, very little response from the Savannah District. And then CRD, of course, we had great coordination with CRD. So we went through the CMPA permitting. One of the challenges, one of the primary challenges that we faced was, again, the letter of no objection from property owners, particularly over in Riverside. Right, so with a lack of cooperation, we had to reduce the scope of the number of outfalls that we were making improvements on. Okay. Again, final plans, as you know, with the improvements that are happening now currently, but working back from that, we have the Talmadge outfall improvements, which is an upstream drainage project unrelated to this particular project that was making stormwater improvements up Macon, up Talmadge, adding curb and gutter, those sort of things, further upstream, increasing capacity there. And so the Talmadge Avenue outfall expedited to coincide with the upstream drainage improvements ahead of the Highway 17 paving. Right, so the paving's occurring right now on Highway 17. So the project had to coordinate with this project, had to coordinate with that paving project as well as the upstream drainage improvement project. And then where we're at right now, the remaining two outfalls on Lanier Plaza, just to the north of this in Lanier Plaza, as well as on Cook Street. The Parkwood Drive outfalls, and then 6 of the 9 outfalls that we identified in Riverside. 1, again, could not be located, and 2, the property owner could not be located, and then 2 of them were not approving of the project. Again, looking ahead, the city intends to post this for construction in the near future. And also, city plans to utilize SPLOST and other available funding mechanisms for construction. Again, we'd like to have special thanks to these agencies, to CRD, NOAA, and GDOT, as well as the Army Corps of Engineers. We've been coordinating with Chatham County and the City of St. Mary's on some of their technologies and some of the things that they've been implementing, and gotten some input from them and some coordination. Been really good, very good help. And that's all. We can take some questions. Yes, sir, in front. Young man.
The Army Corps of Engineers, their nationwide permit would take over a year to respond.
We know. There's a lot, you know, outside of physically going to Savannah, knocking on the door, it was emails, phone calls. There was some turnover.
There's always turnover there.
I get it. It was just no coordination.
It used to not be that way.
I understand. Yes, ma'am. Jill.
Do you guys have like an existing, or will you have a new like maintenance plan for these moving forward?
Yes, we will have a maintenance plan going forward, and that's one of the benefits to the head wall on there. Is he showed a couple of the existing ones are so easily silted in, and I think this head wall will help us, allow us to keep those ends open and clean and keep these pipes flowing. So yes, they will all kind of fall under our maintenance program on those.
I know Chatham County, when they did a lot of their projects, they also developed a maintenance plan along with the
Let me talk about maintenance for just a moment. Thank you, Kara. We were very concerned about maintenance, not just on the head wall design, but on the type of tide gate that we looked at and finally designed. So let's go back to the alternatives. I think it's very helpful for you guys to understand, for everyone to understand the risk and the challenges involved in these two things. So again, these two options we weren't very interested in. This has not shown to be very, very helpful, very maintainable over the time. This, you're still having a situation where the storm sewer infrastructure is all underwater. constantly underwater. You have to pump out the water in order to clean it. So we get into these two options. Again, good technologies intended to hold the tide back, if you will. However, with this particular option, where you're slipping in a tide gate into the pipe, right? Let's see if I can get it right here. This end here, or the bottom of the pipe, or the tide gate here, this has to always be able to open up when stormwater is coming out, right? So if you have the tide here, right, it won't be able to open up. But when the tide drops, it can flap up and open up. Now, that's one of the challenges. The second challenge that you might not always think about, go ahead to the slide here, excuse me. If you're installing a slip-in tide gate in this location rather than an exterior one, what often happens, to Garrow's point about maintenance, is that you're going to get sediment buildup at the end of this pipe, right at the bottom of the pipe, right? And so if you get sediment buildup from the tide, in front of this, what the city depends on, or what they're banking on, is essentially the vendor saying, yeah, that tide gate's going to open up and clean itself out when you got sediment on the bottom of it. That's not a risk that the city wants to take, because then they're pretty much having to maintain this outfall constantly in order to ensure that the flap gate's going to open up. And so alternatively, you look at these exterior gates, even when, go back, even when sediment is built up here, and we can lower this down not just for the flange, for the tide gate, but also for sediment deposits. But when sediment builds up, even if it's flush with the ground, when sediment builds up, stormwater can still evacuate. It can still get out through the top of the system. And go back to the other slide. It can still exit out right here at the top. Stormwater still comes out even though this could be closed by sediment, debris, or any type of obstruction in the front. That's what an inline check valve, we haven't seen it operate that way, where it can still open up when there's debris and sediment at the bottom. When there's debris and sediment at the bottom of these exterior valves, the flange can open up at the top to still allow some stormwater to get out. Yes, ma'am.
So it opens part of it.
Yes, it's an exterior type of, I don't know, it's like a big elongated flange that opens up, like a duckbill shape. Yeah.
Can you manually do that too? Like,
You can, yes, you can put somebody in the water with a crowbar and open this up if you wanted to.
I've done that.
Yes. With this one? With this one? Yeah, yeah. It's not. It reduces the amount of maintenance that occurs at the outfall. When you have these tide gates in, it doesn't eliminate the maintenance, obviously, but it can help with a factor of safety on the sediment buildup and still allowing some stormwater to get out by the opening of the remaining of the duckbill shaped tide gate. That was why we went with this style. Again, in a situation where the invert of the pipe was much higher than the ground underneath it, this could certainly be an option to consider. It's less exposed to the elements, but in this particular Yes, sir, up front.
Just back on the maintenance.
Yes.
Part, for these newer ones, what about biofouling? So how quickly do the barnacles grow on?
They can grow pretty quickly. They really don't, what they can do, gosh, I need to get to the other one. So yes, they can build up here on the bottom along the head wall, really wherever that high tide mark is really going to be seen. But yes, they can attach to the bottom, they can attach to the apron, they can attach to the concrete. In my experience, they're going to attach to the concrete and to the riprap before they attach to the tide gate. Doesn't mean that they can't, but you're still going to get some growth there potentially. Anything else? Yes, ma'am.
So for large debris,
Yes.
since the bottom can be, the top can still come down to the large debris if it's just in the way.
Correct.
Very easily, right?
Correct. Debris from upstream can still get trapped here. Okay. It can get trapped here. It's less likely to get trapped here, and it's not going anywhere here. It's less likely that upstream debris can get trapped in this scenario as opposed to these others. Yeah. But again, with debris caught up in the front here, again, with these other situations, stormwater still doesn't have the possibility of exiting. And that's why the city wanted to investigate these further and put those into the design. Anything else? Thank you.